Pressure. Don't forget to subscribe, like, share. In this video, we learn about pressure. Pressure P is the force F acting on a surface divided by the area A of the surface. P equal F by A. The SI unit is Pascal. PA, or Newton per square meter. Pressure P at a certain depth h of a liquid with density ρ under the influence of gravitational field strength G is given by P equals h ρ G. Principle of conservation of energy. F1 times D1 equals F2 times D2. Density of water, ρ, to be 1000 kg by meter to the power of 3. Acceleration due to gravity G, to be 10 Newton by kilogram. A cylinder full of water with 4 different horizontal outlets. From which outlet would the water travel the furthest horizontal distance of water? Pressure in a column of water is given by formula P equals h ρ G. Where ρ and G are constants. Pressure increases with h, depth of the water. Thus, the water pressure is highest at position D. In a container of water, there is a cube with sides of 10 cm and a mass of 800 gram. Density of water, ρ, to be 1000 kg by meter to the power of 3. Acceleration due to gravity G, to be 10 Newton by kilogram. Calculate the difference in pressure between the top and bottom surface of the cube. Cube with 10 cm sides. W is the weight of cube. HA is depth of top surface cube from water surface. HB is depth of bottom surface cube from water surface. PA is force on the top surface of cube. PB is the force in the bottom surface of cube. PA equals HA times rho times G. PB equals HB times rho times G. PB minus PA equals HA minus HB times rho times G. PB minus PA equals 1000 Pascal. Calculate the net force on the cube in the water. Weight of cube equals m times g. Equals 8 Newton. Upward force due to water pressure. F equals P times A. Equal 10 Newton. While upward is positive net force on cube. Equals upward force from water pressure minus weight of cube. Equals 2 Newton. The cube will float on the surface of the water. A manometer is filled with water and mercury. Both arms exposed to the atmosphere, and the height of the columns in both arms reach an equilibrium. We note that calculate the pressure exerted by the water column. Pressure of water. P equals H rho G. equals 12,000 Pascal. Calculate the value of D. Pressure exerted D minus 1.5 meter mercury column equals pressure exerted by 1.2 meter of water. H rho G equals 12,000 Pascal. We get 1.59 meter. The siphon is created by filling a hose completely with water and keeping the two ends submerged separately in the water in bucket A and bucket B. We know about this parameter. The height difference, h, is measured to be 0.6 meter. Calculate the pressure difference between two ends of hose. Pressure difference, P, equals H rho G. Equals 6,000 Pascal. A hydraulic press is used to lift a car. We know about this parameter. Calculate minimum force exerted by piston 1 to lift the car. Force on piston 2 equals weight the car. F2 equals 12,000 Newton. Using Pascal's principle, pressure P equals F1 by A1 equals F2 by A2. F1 equals 960 Newton. A hydraulic press is used to lift a car. Noted that what is the distance moved by piston 1 if the car is lifted by 0.4 meter? Principle of conservation of energy. Work done piston 1 equals work done piston 2. T1 equals 5 meter. The atmospheric pressure at sea level is 1.013 10 to the power of 5 Pascal. Calculate the height of the water column of a simple water barometer at sea level. Pressure due to the water column. P equals H rho G. .13 meter. What is the water column of a simple mercury barometer at sea level? Pressure due to the mercury column. P equals H rho G. .75 centimeter.